The speed of a stream is 4 miles per hour. That's the current of the stream here. So if you were standing on the side of the river here, and you were looking at the water would be going 4 miles per hour. If a boat travels 100 miles downstream is when the current is helping you, it increases your speed. If the boat travels 100 miles downstream in the same time that it takes to travel 50 miles upstream is when you're fighting the current, so it slows you down. We want to find the speed of the boat if there was no current, if the water was still. All right, so what we're going to do is we're going to set up a table, a distance, rate, time table. And we have two situations here. We have the downstream situation and the upstream situation. So we have downstream and upstream. And I want to write things for the distance, rate, and time for each situation here. So I'm going to make a table. This column I'm going to do is distance, and then I have a rate column, and then a time column. Now let's think about the distance first. It tells me that I'm traveling 100 miles downstream. 100 miles is a distance. So I'm going to put 100 for the distance downstream. And then I'm going 50 miles upstream. That is also a distance. Now the rate depends on how fast the current is, 4 miles per hour. I'm looking for the speed of the boat if there was no current. Let's let that be X. So if the current is 4 and I'm going downstream, then that 4 is adding to my speed of X. So downstream, the speed is going to be X plus 4. The stream is speeding you up. Now upstream is when the current, you're fighting against it. So it's going to slow you down. So if you were going X miles per hour, the 4 miles per hour would slow you down. So it's going to be X minus 4. Now we don't have anything about the time except for that the times are the same. To fill in the time column, I'm going to use the formula. The formula for distance, rate, and time is D equals RT. And if you solve this for T, just divide both sides by R. And you have an expression for time here as distance over rate. So what I'm going to do is I'm going to fill in this last column using the distance and rate that I found earlier. So this time, distance over rate, for downstream, I'm going to do 100 divided by X plus 4. I'm going to do the same thing for the time upstream. I'm going to use distance over rate. Its distance is 50 and the rate is X minus 4. All right, now I'm going to write an equation. Something in the problem usually gives away how to write the equation. The thing that gives it away here is that the times are the same. That means the times are equal. This is an expression for the time it takes to go 100 miles downstream, and this is an expression for the time that it takes to go 50 miles upstream. And it says that those are the same, so I'm just going to set them equal to each other. So 100 over X plus 4 is going to equal 50 over X minus 4. And there you go. You can solve this equation now for X, and X is what I'm looking for. That's the speed of the boat if the water was not moving still. Now, since it's a fraction equals a fraction, I can cross multiply. All right, so cross multiply, I'm going to have 100 times X minus 4. I'm going to put X minus 4 in parentheses. And then 50 times X plus 4. And I'm going to put X plus 4 in parentheses. All right, now I'm going to distribute the 100 of 100x minus 400. Distribute the 50 on the right-hand side at 50x plus 200. I'm going to collect the x terms on the left by subtracting 50x on both sides, adding 400 on both sides. So on the left side, I'm left with 50x. And on the right-hand side, 200 plus 400 is 600. And then you will divide both sides by 50. So the x is what I'm looking for, the speed of the boat in still water. 600 divided by 50 is 12. So yeah, x is the speed. Since the stream speed is in miles per hour, the boat speed is also going to be in miles per hour. That's the speed of the boat if the water was still, no current. There you go.